Welcome back to the GCSE Maths Pro YouTube channel. Today's video is the third and final part of upper and lower bounds, where we'll be looking more specifically at questions where they say, by considering bounds, calculate something. Definitely make sure you've checked out the first two videos in this series. The first one is actually how to just work out upper and lower bounds in general, and the second one is then inputting that into formulas and more complicated calculations, which will then feed into this one. So the questions we're going to look at are the ones where you might have seen it says by considering bounds, and then it just says calculate the value of something. It doesn't actually tell you whether to calculate the upper or the lower bound. And as you can see here, it says the value as in one answer, not two. So in this case, when it says by considering bounds, calculate the value, singular, of something, it basically means we need to work out the upper bound of, in this case, f, and the lower bound, and then come to a decision using a suitable degree of accuracy as to one final answer. Okay, so you're considering both of the upper and the lower bounds, and then you're going to choose a final answer. So normally these are quite a few marks because you've had to do both the upper and lower bounds, and it's in some form of calculation. So in this case it says calculate the value of f to a suitable degree of accuracy. Don't worry about the degree of accuracy yet, we're just going to deal with working out the bounds first. So they've given us the formula. F is equal to P times A, and they've given us values for P and A, which are obviously correct to certain measurements. So in order to find F, I need to times these two values together. You might have seen this in our first video at the end where we started looking at a couple of more straightforward calculations using upper and lower bounds. Let's say I want to work out the lower bound of F first. So the lower bound of F is the smallest possible value of F, isn't it? I need to work out, based on my calculation, which is multiply, do I need the smallest possible value of P, or the biggest, or do I need the smallest possible value of A, or the biggest, right? So I want the smallest answer when I times together two values in this case. Timesing together two values to get the smallest answer means I'm going to need those two values to be the smallest in themselves, aren't I? So that means I need the lower bound of P times by the lower bound of A. So you have to make that decision yourself. Do I need the upper bound, the lower bound? Do I need a mixture? In this case, to find the lower bound of F, I need both the lower bounds of A and P. And in the same way, if I want to find out the upper bound of F, to find the biggest possible value of F, I want to times together the biggest possible values of P and A, the upper bounds of P and A. So I need to work out the upper and lower bound of P and A first. So I'm going to use my method that I used in the first video, which is the number line. You can obviously just do it yourself manually if you're happy to do so, but because it's significant figures, I find it a bit easier to use this visual method. So for P, I'm going to write down the number, which is 5. So we've got 5 newtons per meter squared, correct to two significant figures. So that means I need to look at the second significant figure, which in this case is the 0. So we want one above and one below. So one below is 4.9. One above is 5.1, and obviously remember, we're going halfway. Because I'm working out the upper and the lower bound of F, I'm going to need both the upper and lower bounds for P as well. So lower bound is 4.95, so halfway, and the upper bound would be 5.05. Now, the reason why I've chosen 5.0 is because it's quite easy to think that you need to do 5.5 and 4.5, but it's not, because it's two significant figures. Okay, so just be really careful. Sometimes they'll choose numbers deliberately like this that are a bit more complicated. So I've got those. Then let's just quickly do A as well. So in the middle, we've got 2.19 meters squared. Now this is to three significant figures, which means I'm looking at the third number, which is 9. So one above and one below. So one below is 2.18 and one above is 2.2, and I'll put a 0 just to make it look the same. And then obviously halfway. So lower bound is therefore 2.185, and the upper bound is 2.195. So now I've worked out both of these, I can just literally put them into my formulas and straight into the calculator. So the lower bound of F is multiplying together the lower bounds of P and A. So the lower bound of P, let's label this, shall we? This is P and this is A, isn't it? So the lower bound of P is 4.95 times by the lower bound of A, which is 2.185, and then I'll just chuck that in my calculator. Now I'm just going to write down all the digits. If there's more than this, maybe just write down 4 decimal places for now, but in this case I'm just going to write them all down. So I've got 10.81575 575. Okay, and then we do the same for the upper bound of f, means I need the upper bounds of p and a. So we've got p, which is 5.05, and a, which is 2.195. Again, just chuck it in your calculator. So here I have 11.08475. Okay, we found the upper and lower bound of f. Now, we're coming back to this part here. It says calculate the value, just one, okay, with a suitable degree of accuracy. So I'm going to look at both of my answers, 10.81 and then 11.08, and just look at what do they both round to. Okay, I know I've got a lot of decimals here, but just kind of look at it really straightforward. They both round to 11, don't they? In the case of if I were to say round it to two significant figures or round it to the nearest whole number, they would both round to 11, wouldn't they? And that's the number that I'm therefore going to choose. So I'm going to write here at the end, therefore, my final answer is f is 11. Now, f is newtons, which I'll probably give you, but anyway, 11 newtons in this case. And you have to normally give a reason for your answer. So what they mean by the reason is, why did you choose 11? You just say, because to whatever you rounded it to, and so in this case it's the nearest whole number, isn't it, or to two significant figures if you like, to the nearest whole number, they both round to 11. That's kind of your reason. Okay, so whatever you end up rounding it to, obviously the numbers are different in each question, right? You might round it to the nearest whole number, you might round it to one decimal place, you might round it to a certain number of significant figures. Whatever it is, they should both round to that, okay? They should both round to the same number, and you just say your reason is because when rounded to this, they both are the same. Okay, so that's basically your 5-mark question. It's a lot of work, but I think once you know what to do, it's not, too complicated in itself. So let's look at another one. Now this one's a bit more complicated because before we just had two numbers multiplied. Now we've got some square root, some divide, all of that. And also if we have a read of the question, it says, by considering bounds, calculate the value of g to a suitable degree of accuracy. Now if you have a look, g is not currently the subject of the formula. So they might also do that as well. You might actually have to go into a bit of rearranging and changing the subject first. Okay. So in this case, I'm going to, first of all, before I even deal with the upper and lower bounds, I'm going to just rearrange this formula so that I can have g as my subject. So I'm obviously going to have to times by h to move that across. So I've got fh equals the square root of g, and then to get g I just need to square both f and h, isn't it? So f and h squared. Okay, so that's actually my formula I'm going to use. So just double check, have they actually given me the formula with the correct subject to start with, because that could also be an extra trick question. Now from here, we're going to do exactly the same we did in the previous question. I need to know, okay, I'm going to find the upper and lower bound of g. So for the lower bound of g, looking at my formula is now f times h and then squared. So it's all multiplied. I don't have any divides anymore, luckily. Everything is timesed or squared, which means that I'm going to, when you've got adding or timesing in formulas, you're either going to use both upper or both lower bounds. When you've got divide or subtract, that's when you start having to mix them together, which we'll see an example in a minute. In this case, I know that for the lower bound, for the smallest possible value of g, I need to times together and then square the smallest possible values of f and h, don't I? So I need the lower bound of f times the lower bound of h, and technically they're then squared, aren't they? Okay, and then therefore for the upper bound of g, the biggest possible value of g, I'm going to need the biggest possible value of f and h to times together, and then squared. So I've got that. Now we're just going to go through and, as before, work out the actual upper and lower bounds of f and h first. So f is 5.8, correct to one decimal place. So again, you might not need to draw out this diagram. You could just figure it out yourself. If you're happy to do so, that's fine. So I do one decimal place below, one above, and then go halfway. I just find it's helpful to lay it out like this. So 5.75, and the upper bound is 5.85. Okay, so that's for f. Now for h, we've got 6.27 to 2 decimal places. So I'm looking at the second decimal place, one above, one below. So 6.26, and one above is 6.28, and then obviously halfway. the lower bound is 6.265 and the upper bound is 6.275. Now, in this case with decimal places, you're kind of just adding on an extra 5 or taking away a 5, isn't it? So they're a bit more straightforward to do without drawing this whole diagram, but it's up to you. So we've got that. We're now just going to chuck them into our formulas. So the lower bound of G is the lower bound of F, which is 5.75, times by the lower bound of H, which is 6.265, and then squared. Don't forget that you've got to square this one, which we will chuck in the calculator. Okay, I'm going to write down pretty much all of those decimals just so that when I go to choose how to round at the end, I can compare everything. So I've got 1,297.71. Okay. And then the same with the upper bound. I just need to use the upper bound of F, 5. Oh, I put my decimal place in the wrong place there, haven't I? 5.85. There we go. That's more accurate, isn't it? 5.85 is my upper bound for F times by 6.275, which is the upper bound of H. And again, don't forget to square it in this case. Okay, and then we've got 1,347.53 ... Okay, so we've got our upper and our lower bounds for G. Now we just need to choose a final answer that they both round to. So in this case, because we've got quite big numbers, we've got in the 1000s, I'm looking at what they both round to. In this case, the decimals aren't actually that helpful, are they? I'm just going to look at bigger numbers. So I would say they both round to 1,300, don't they? So to either to two significant figures or to the nearest 100. So I'm going to say, therefore, G is 1,300, because they both agree with that, don't they? And when it says give a reason, again, we're just going to copy and paste what we said in the previous one, but obviously we've now rounded it to the nearest 100. There we go. So because to the nearest 100, or if you wanted to say to two significant figures, that also works, they both round to 1,300. Okay, so it's kind of the same reason as the previous one, but obviously just depending on what you've actually rounded it to. Okay, so that's everything on upper and lower bounds. If you found this video helpful, please make sure to like and subscribe, and do leave down below any questions that you might have.